In this video, I just want to go over some of the key concepts that you'll really want to have a good handle on before Monday's test. So in specific, we're talking about inheritance, interfaces, and abstract classes. Let's just start with inheritance. If I'm going to write a class that inherits from another class, the keyword that we need here is extends, right here. So if horse is an animal, therefore public class horse extends animal. So, and we would say in this case, horse is an animal, which is different from saying a horse has a mane, for instance. So this is an example of inheritance. This is an example of composition. All right, now some newer stuff this week was with respect to an interface, and we have two key words we use with interfaces. One, when we actually create an interface, and when we create an interface, we actually write public interface writable. And recall that this is a completely abstract class. Completely abstract class, and in this class we have methods, but no methods with no implementation. Method names, but no implementation. Now, down here, if I want to use the writable interface, public class horse implements writable. And when it implements writable, it must implement all methods in writable. Implement all methods that were listed in writable. So in writable, we write what methods it's going to have. Horse is going to actually write the code for those. All right, abstract class. An abstract class is some abstract methods, but not all. Some abstract methods, but not all are. But not entirely. Or not, how do I want to say this? Oh, let's undo that. But not all methods must be abstract. Not all methods must be abstract. So when we create an abstract class, because it is abstract, it's going to have the word right here, public abstract class shape. And then when we want to have something that extends it, this is actually inheritance. So this goes back to inheritance. So our rectangle inherits from shape. Now here we will have to add code or implementation. We'll need implementation for abstract methods in shape. So for example, you'll recall in our example of public abstract shape, we had methods like public abstract. Well, I don't think we had to write abstract there, but we would say we would go back here. We would have public double get area. And this method simply had a semicolon there because we didn't define it here because this was an abstract class. Down here, when we created a rectangle that was a shape, then we had to define exactly how to get the area, and we just did length times width. All right, so this is a little diagram of what we had here. This goes back to the writable example with a horse that is an animal and it's also writable. And I want to talk about what kinds of objects we can create. Can we say writable R1 equals new writable? That looks like code we use all the time, but this is not allowed, and the reason is because it's an interface, and an interface is abstract, and you cannot create an object of an abstract class. The next one, writable R2 equals new horse. That will work because a horse is a writable. as will writable R3 equals new car. That will also work because a car is a writable. But bear in mind here that you will be restricted to methods that writable has available. So once you say that R2 is a writable object, even though it's a horse as well, you can't use horse-specific methods unless you cast R2. So like you could do something like this. Horse R2 dot, what could a horse do? Eat hay. All right, not all writable objects eat hay. Clearly a car does not eat hay. So if you wanted R2 to eat, or even just eat, never mind, cars don't eat either. So, maybe we just say, if we were to add such a method, R2.eat, it wouldn't be happy if it was just a writable, but if we cast it to a horse, then a horse knows how to eat and we'd be fine. Now here's some other declarations. Horse 1 equals new writable. This does not work because a writable is not necessarily a horse. So writable is not a horse. A horse is a writable, but a writable is not a horse. Same thing with car 1 equals new writable. That cannot work either because a writable is not a car. These last two are the way we've always learned to do these. Horse H2 equals new horse, that's good. And car C2 equals new car, that's good. We can create objects that way because these are neither interfaces nor abstract. All right, we're going to look at the same thing here. The difference here is we had multiple layers and we had an abstract class named shape. So can we say shape S1 equals new shape? No, we can't because it is abstract and we cannot make an object of an abstract class. The rest of these three all work. Shape S2 equals new rectangle 1, 1 is fine. Shape S3 equals new square 1, and shape S4 equals new circle 1. All of those work because a rectangle is a shape, a square is a shape, and a circle is a shape. Notice even the square, even though it goes up 2 levels, that's fine because it is a shape. Let's go to the next one. Here we've got all rectangles. Can we say a rectangle R1 or rectangle R1 equals new shape? And we can't because a shape is not a rectangle. So that's going in the wrong direction. So you'll notice that, let's go back to the previous slide. We can have the more general out here. So the more general here, or the parent class, we could call it, parent class out here. And here we have the more specific, or the child class out here. And that can be done unless, yeah. So that's why this doesn't work. Rectangle is the subclass and shape is the superclass. Clearly, rectangle R2 equals new rectangle 1, 1, that's good. Here, rectangle R3 equals new square, that works because we can see from a diagram that a square is a rectangle, so that's good. And rectangles and circles clearly are not related. There's no arrow between them, and so that one will not work. Lastly, these both work. These are just the obvious ones. I can do circle C1 equals new circle and square S1 equals new square. All right, I want to just also review our big terms, encapsulation, inheritance, and polymorphism. And the code that you see here is the code that we were using in class with just this past Wednesday with rectangle and shape and then shape tester. And I want to talk about where do we see our ideas of encapsulation, inheritance, and polymorphism. So let's start with encapsulation. I'm going to try doing this with a highlighter. So for encapsulation, I'm going to highlight in yellow here. And what makes this encapsulation is encapsulated inside of this rectangle class. I've got my private variables, I've got my constructor, and I've got the methods. So that in this inside this class, all the things I need for rectangle exist right here. That is encapsulation. Now let's move on to inheritance. Inheritance, we can see we have inheritance anytime we're extending from another class. We can also see inheritance here where we call on the superclass's constructor. We didn't choose to here, but any place where we called on super dot and a method name would be another example of using inheritance. And then lastly, polymorphism, where we really see polymorphism in play is right down here. You'll notice in this code here, I've got shapes which has a rectangle, circle, and a square. And yet right here, I can call on the same method for all three, even though they're different kind of objects. So that probably needs a little more notes. So let me just add that in here. But right here, some are, let's see, we have a rectangle, we have a circle, we have a square, and each calls on its own method. Each calls on its own getArea method and its own getPerimeter method. So that's polymorphism, where we can have these grouped and we have the same method, but each of these objects, even though they're all a shape, they know that, hey, I'm a rectangle, I'm going to use the rectangle getArea method, or I'm a circle, I'm going to use the circle getArea method. All right, I hope this helps out for your test.